A motorboat going downstream overcame a raft at point A. 60 minutes later it turned back and after some time passed the raft at a distance of 6 kilometers from point A. Find the flow velocity, assuming the duty of the engine to be constant. Let's visualize this situation. Here's a river flowing from left to right. At point A, a raft floats on the water. It drifts with the current. A motorboat passes the raft at point A, traveling downstream. The motorboat travels downstream for 60 minutes. After 60 minutes, the motorboat turns around and heads back upstream. Meanwhile, the raft has been drifting downstream with the current. The motorboat heads upstream and meets the raft again, 6 kilometers from point A. Let's define our variables. We'll call the boat's speed relative to water v sub b, and we'll call the flow velocity v sub f. This is what we want to find. Here's a clever approach. Instead of tracking both objects separately in the ground frame, let's view everything from the raft's perspective. This makes the problem beautifully simple. In the raft's reference frame, the water appears stationary. The raft just sits still. In this frame, the motorboat simply moves away from the raft at speed v sub b for time t. Then it turns around and returns at the same speed v sub b. Here's the key insight. Same speed, same distance, so the return trip takes exactly the same time t. The total time from first meeting to second meeting is t plus t, which equals 2t. Now let's go back to the ground frame and use this result. In the ground frame, during this total time 2t, the raft drifts downstream with the current at velocity v sub f. The distance the raft travels equals its velocity times the total time. That distance is L, which equals v sub f times 2t. Solving for v sub f, we divide both sides by 2t. Now we substitute our known values. L equals 6 kilometers and t equals 1 hour. 2 times 1 hour equals 2 hours. 6 divided by 2 gives us 3 kilometers per hour. The flow velocity is 3 kilometers per hour.